everyone. I hope you're having a good day. It is a privilege for us to introduce the first online video lesson, and I, Edberg Soans from the Department of Chemistry, Westminster School, welcome you to watch this video. This video is going to share some information about chromatography that you have learned in grade 9.
By the end of this video, you'd be able to explain how to separate the pigments in ink, separation of amino acids, and calculation of RF value. All of the separations can be carried on a paper, and this is called paper chromatography. In paper chromatography, we make use of a paper which is called chromatographic paper used to separate the components in a mixture. So let us take up a mixture which contains 3 different components. We need to keep this in mind that this is a schematic representation and the paper is actually placed vertically. So let us take the 3 different components as a mixture. We have green, we have the second component red, and also the third component blue. Altogether they form the mixture which we have to separate. We make use of a solvent which is used to move the components from their places. The solvent starts moving from the base of the paper and it moves ahead due to capillary action. And as the solvent moves, we would actually see the components also moving along with it. So after a while, you see that the red ones have been a bit separated from the green as well as the blue ones. So you can see them at 3 different places. Though they were all mixed together initially, now they have been placed at 3 different places. And this is due to the movement of solvent on the paper pushing the components at 3 different places. So this is the first one, that is red, second and the third. So let me call it as 1, and then we have the green ones as 2, second component, and the blue ones as third components. So if you see them on the first place, you would see them all mixed, the 1 and the second one and also the third one. So they are moving at different distances. So what would you see if the solvent still moves ahead? Definitely the solvent will move ahead, and you should be able to see that the components have been separated. So you see here that red ones, the first, second, the green ones, and the third one, the blue, they have separated, and this separation you can see clearly on the paper. So the separation actually takes place by 2 important reasons: the solubility of the component in the solvent, also the attraction of the component to the paper. If you compare the 3 components, all the 3 have different solubilities. For example, if you check on with red, they have the least solubility compared with the green and the blue ones. That is why they stay back much ahead of the rest of the 2. The green ones may have a little more than the red, and the blue ones have the most of solubility. The second factor that we consider for the separation is the attraction of the components on the paper. So it is the attraction to the paper. So we have the red ones which is most attracted, that is why they would stay. And the green ones are less attracted than the red ones. And the third one, that is the blue ones, are least attracted on the paper. So we have the first factor, solubility, and also the second factor, which is attraction towards the paper. So these are the 2 reasons why the separation of the components take place on the paper. So we have learned that the mixture from the beginning, it was all together. After a while, when the solvent started moving, it also separated them based on these 2 factors, and at the end we have the 3 different colors at 3 different places. Moving on, we now learn how can we separate pigments in ink. We all must be aware that ink has a lot of colors. It may be a mixture of 2 or 3 pigments. So let us take an example, say a black spot which may have 2 or 3 pigments in it. So I take up a ink spot and spot it on the chromatographic paper on the base. And then I take water as a solvent. Now in the first, that is in the start, the water level starts moving. And you know, as the water moves, you see that the spot gets separated on the paper. So here we have, in the second picture, we have 3 different colors. They're not very much apart, But you can see them forming 3 different colors, and the final one you see them at 3 different places. So this is what happens when you separate the pigments of the ink. This can be done on the paper, and paper chromatography is best suited for separation of pigments in the ink. But what if the solutions are not having any color? So how do you go about it? Let us see. Say we have to separate colorless substances. So we take up a chromatographic setup as described here, as displayed here. So I have a chromatographic paper which is placed on a cylindrical jar, and then you see a baseline there which is drawn using a pencil. So I spot the mixture. Say I take up an example of a mixture of 2 amino acids, and both the amino acids are colorless. So I spot them, and then I'm loading the jar with the solvent. The solvent here that we use is actually a mixture of 3 substances: butanol, acetic acid, and also water. So this together comprises of the solvent which is being used to move the components, that is 2 amino acids. So as the solvent moves, you would actually see the solvent which has moved till the top, but you would never see any other things, any colors on the sheet. So how do we actually know where are the substances being moved? So in this case, we make use of a locating agent. Now what is a locating agent? It is a substance or a solution which is used to see the separated components on the paper. The best example is ninhydrin. Now ninhydrin is sprayed on the paper, and the paper is then dried. So we dry the paper. After some time, when it is dried, you should be able to see 2 different spots at 2 different places, and these are nothing but the amino acids which has been moved. So we have separated the 2 different components in the mixture which was on the spot, and these 2 substances are 2 different amino acids. We must appreciate the using of ninhydrin, because without which we would not be able to see any of the separation. So locating agent is very important, and the example that we used here is ninhydrin. That is how we separate colorless substances. We come across a term called RF value in chromatography, which is called retention factor or retardation factor, which can be formulated as the distance moved by solute divided by distance moved by solvent. Now if you take up an example on a chromatographic paper, having a baseline and the spot, and then they give you the value, say the solvent has moved up till 8 centimeter on the top of the paper there. And then you can also see that the solute, which is the component, has moved to an extent, to some distance, and maybe this distance we can measure it, and this can be found to be around 4.5. So the distance moved by the solute is 4.5 centimeters, and also the distance moved by the solvent is 8 centimeter. Now this is only an example to see how we can calculate the RF value, that is distance moved by solute divided by distance moved by solvent. So we have the RF value for this component based on the data, that is the values that we have. So we have RF value is given as the distance moved by solute is 4.5 centimeters divided by the solvent is 8. So you should be able to answer this easily. So before we wind up, let me tell you, RF value is always a unique value for each component. Answer for this one, 0.5625.
I hope you enjoyed watching this lesson, and I really hope this lesson was informative to you for your learning. We hope to have more of these videos in the future.